Hi everyone, welcome to the fourth seminar of the edition of ESIC that is going to focus on innovate agriculture using less soil and precise irrigation in international cooperation. Today we have two speakers that are Giovanni Bazzocchi and Nicola D'Alberton. Giovanni is an agroecologist and a professor at the University of Bologna, and is going to talk about hydroponic horticulture. Nicola is a research fellow at the University of Trento, and he's going to present us the project that he's working on in Lebanon about precision irrigation and enhanced water management. And I would like to remind everyone that the seminar is recorded, and as soon as possible, we'll upload the video on YouTube channel of the official channel of Cattedra UNESCO. So the first presentation will be from Giovanni. So, and after will be the time of Nicola. I kindly ask you that if you have questions, to keep that for the end of the presentation, both of the presentation, so we can have a discussion at the end of the two presentation. So Giovanni, if you want to start.
Yes, thank you. Good afternoon, everyone. Thank you for the invitation. I share my presentation, if I can. Okay. Can you see the presentation?
Yes.
Yes.
Okay.
Yes, not in full screen.
Yeah. Okay.
Perfect. Thank you.
Thank you again for the invitation. I'm Giovanni Bazzocchi, and well, briefly introduction, because I'm not an horticulturist. Actually, I'm an entomologist and an agroecologist. But I also am a member of the ResCUE-AB, that is the research center in urban environments for agriculture and biodiversity, that I founded with some colleagues of horticulture more or less 10 years ago. The ResCUE-AB is based at the Alma Mater Studiolo, University of Bologna, Department of Agriculture and Food Sciences. Sorry, I can't. Okay. And the topic of this presentation is simplified soilless horticulture systems in context with limited resources. Well, this kind of systems are known in the scientific, also the generic literature, in various ways. So, for example, hydroponic simplified or soilless simplified systems, micro gardens, and so on. So may happen that I will call them in different ways. I'm sorry. But how, as an entomologist, did I end up meeting this kind of systems? Well, are many years that some researchers have realized that that conventional and industrial agriculture is a crossroad. And this as a crossroad because it's environmental and economic and social impact. Here's just some data on maybe you know, on the environmental impact of food and agriculture. 26% of the greenhouse gas emission come from the food sector. 50% of the world's habitable land is used for agriculture. And the rest is mainly occupied by urban areas, of course. 70% of global freshwater withdrawals are used for agriculture. Eutrophication is for the main part caused by agriculture, and so on. The impact on biodiversity is very, very big. As I said before, in 2006, I met Giorgio Gianquinto and Francesco Orsini, professors of horticulture at the University of Bologna. They were involved in urban agriculture. As you know, within 25 years, more or less, the population, the world's population living in cities will be more than 70%. So on this basis, we founded some years after our meeting the ResCUE-AB. The ResCUE-AB that is, of course, as you can say, a variegated group of researchers which brings together expertise in the field of horticulture, but also entomology, biodiversity, and so on. The lab contribute to a range of interdisciplinary activities in the field of horticulture and biodiversity, both in Europe and in several countries of the so-called global south. Well, but what is the soilless agriculture? The root of soilless agriculture are very ancient, about 3,000 years ago. For example, in the city of Deir el-Bahari, near Luxor, in Egypt, there is this funerary temple where there are some hieroglyphs that depict plants grown in water without soil. With a big jump in about 590 BC, were built the hanging gardens of Babylon by the king Nabucodonosor II, that are considered one of the 7 wonders of the ancient world. But also on the other side of the world, in America, the Aztec, the ancient Aztec, the nomadic Mexican tribe, built the city Tenochtitlan, that is Mexico City nowadays, and on the lake Texcoco, where vegetables, but also fruit trees and so on, were growth on floating gardens called chinampas. Well, maybe they were not exactly floating gardens. Probably they were artificial islands, but the main concept is the same. And also today, there are some Mexico City, and use of chinampa continued anyway until the last century. So in China, in the 12th century, ornamental plants and flowers were probably grown in floating garden, as according to some author, indeed Marco Polo refers to some floating gardens encountered during his trip in China, in describing the median. In Burma, Myanmar, also today there are floating gardens in the Lake Inle, where tomatoes, potatoes, and other vegetables are grown in these islands, in these floating gardens. Well, the hydroponic systems today, in the 20th century and also more recently, in the last 20 years, soil cultivation technology has seen an exponential growth, paving the way for the widespread adoption of high technology soilless culture in intensive farming. This system did offer the growers many advantages, such as precise environmental control and automation. Actually, many of the vegetables we daily consume are grown in hydroponic greenhouses, or even in indoor vertical farms. Also in our department, thanks to Horizon program project, we built a vertical farm for research and studies, objective, of course. Well, the advantages of soilless agriculture are not necessarily linked to high-tech technology. The basic concept of hydroponic is that we can provide water and nutrients near the roots of the plants. And this is an advantage from the grower standpoint, because in this way the plant doesn't need to invest most of the energy in the root system, as happen in the soil cultivation, because the roots in the soil cultivation, of course, have to search water and nutrients in the soil. And so at the end, almost the 70% of the biomass of the plants is in the root system and not in the air parts of the plant. Okay. In hydroponic system, the ratio is inverted because the plants don't need to search nutrients in water because they float on the nutrient solution, in the nutrient solution, and so the growth of the plant is very fast and efficient. This is the standpoint where we started to propose simplified soilless system in social and cooperation, international cooperation projects around the world, starting from the first years of the 2000s. At the beginning in South America, in Brazil and Peru, then in Southeast Asia, Myanmar, in Africa, Mauritania, Sahara Desert, and also in Cote d'Ivoire, and starting from 2018 also in Palestine. Nowadays also a colleague of mine is in Colombia, and we are also following a project in Nigeria. Why going soilless? As mentioned before, of course, there is a reduced need for land and fertile soil. This cycle of the plants is shorter. There is also a reduced needs of water and nutrients, mainly water, and a sort of independence from growing season. For example, where there are some seasons with abundant rains, of course, lower pesticide needs and lower contamination risks also. Also, recently, also FAO proposed the soilless systems, microgardens, for example, in Latin America and the Caribbean, in the context of the project Growing Greener Cities, as a tool to help low-income families meet their daily needs for fresh and nutritious produce. But which are these systems? There are some different systems that I will scroll briefly. For example, this is a floating system that is composed of, as you can say, raised wooden box, whose bottom is waterproofed with a sheet, a waterproof sheet, and filled with water and nutrients, so the nutrient solution. The individual plants are placed in a small pot and or other little container, perforated, in a floating panel. And as you can see, the roots of the plants freely swim, let's say, in the nutrients solution and search for nutrients and water. The oxygenation, the air in the water, that is critical for the plant growth, of course, in this kind of systems, takes place with a small pump, usually, or in absence of electricity, by lifting manually at least 2 times a day the floating panel and moving the water with the hands in the container. A similar system is the simplified substrate system, in which the box is filled of a substrate that can be cocoa coir, cocoa fiber, or rice husk, as in this case, or either inert substrate. Of course, they should not contain or at least release any organic or inorganic elements. If we want to use the nutrient solution, or the box can be filled also with potting soil or local natural soil if is quite balanced and not contaminated. As you can see, the water can be collected and in the lowest part of the box, in the bottom of the box. Of course, a small slope must be made, and collecting the water in a container and to use it for watering the plants. As you can see, we can, in this kind of systems, we can also grow little carrots, for example, but also plants as pepper and tomato, not only leaf vegetables. Of course, we can use also other containers, such as bag, as in this project in Ivory Coast. Another system is based on the technique called the NFT, nutrient film technique, with drip system. In this case, the nutrient solution is pumped from the tank in the bottom part of the picture to irrigation pipe, and from these through capillary pipes and drippers near the plants. So it's a drip system. that are also in this case in a little pot with a little of substrate such as rock wool or again cocoa fiber and so. This actually is the system mainly used also in the commercial greenhouses in our region. But we modifying. For example, this way we use the PVC a PVC gutter, you know, this kind of pipes. For example, in Bologna, in social housing buildings at the 11th floor, Via Gandusia, Bologna. It was a project which saw the involvement of some of the residents of the building that is placed in a fairly problematic area of the city of Bologna. The project lasted 5 years thanks to the collaboration of ResCUE-AB with an association named Biodiversity, and then ended some years ago due to the renovation and the energy redevelopment of the building by the social housing authority. So it's not more running in this moment. But this project was an interesting case study because it was the first social rooftop horticulture, the first horticulture in the rooftop of a social housing building, and also the project has had worldwide scientific and generic dissemination. You can see the orange pipe in the background of this picture, fixed in on the rail and with a little slope. The nutrient solution flows in the bottom of the pipe, and the plants were placed in the holes we made in a little pot, so the roots are watered by the nutrient solution directly. Of course, we have had to cover in the summer with a shadow net because the cultivation, because of the high temperature on the rooftop. We also experimented some other systems in this project, the bottle vertical systems, for example, where the irrigation pipe ran on the rail, and with the drippers, any bottle that hosts the plant is irrigated, and a collected pipe at the end of the bottle collect the water. You can see some picture of this system. We call it flying tomatoes, and we grow many kinds of vegetables in the system. For example, fennel and cabbages and strawberries and basil, and you can say also the plants are very big. Melon here. And tomatoes flying. Okay, there is a video on this project. Same system we proposed in some events in some squares of Italy. Okay, also this system has been proposed in many projects around the world, but the maybe main system we use in our project is the Garrafa SPET system. Garrafa SPET because it was born in Brazil in 2004. So garrafas means bottle in Portuguese. The system works in this way. There is a tank in the upper part, the red circle, in which there is the nutrient solution. The tank in this case is of 300 liters, and the module, because the system can be made by different modules. The single module covers 3 meters per 2 meters, so 6 square meters. From the tanks in the upper side, the nutrient solution falls by gravity along an irrigation pipe, as you can see in the yellow line, and runs on the top of the rows of bottles. There are more or less 12 rows of bottles. Each bottle is connected to the next one by a connection in which the neck of the bottle fits into the bottom of the next bottle by a hole, through a hole drilled in the bottom of the bottle. So the water flows along each row of bottles. And houses 2 plants. So more or less each module can host 200 plants. Of the row, the water is collected by a collection pipe and flow through the tank in the bottom that can be underground. or not. From this tank, the water is then pumped again on the, or also manually transported to the tank on top, closing the irrigation loop. So this is the picture of two modules that can be, so we can have a 446 per 6 meters. As I mentioned, this system was born in 2004 in Brazil. So today, this year, are 20 years of this project. You can see here some picture from Teresina. It is the city of the state of Piauí in the northeast of Brazil, where we have made this project. Okay, the project is quite complex. In these 20 years, it developed a lot, but well, I don't want to steal time to the following Nicola, so maybe we can come back later. Similar systems we also experimented in Myanmar, for example, where instead of the bottles we used the bamboo, as you can see. And also in Mauritania and Ivory Coast. This is the project in Mauritania in the Sahara Desert. So the people from that area didn't see anything like this before the project. Well, this is the last project I was involved in person in Palestine and Gaza Strip. As you can imagine, I have some problem talking about this project in these days, because most of the people I met and worked with in this project, I don't know where and how they are. In February 2018, the main part of the project was in the Rafah refugees camp by UNRWA. So, but UNWRA, that is the UN unit for Palestinian refugees. These are the UNRWA schools, is where, and these are the systems we built with the childrens in the school and the woman in the woman center of the refugee camp of Rafah. In February 2018, floating system, box system, floating system, and Carafa system, bottle system. The bottle system, you can say, we built in Palestine was made by iron and not wood, because the iron was less expensive of wood. There is a big industry of iron because of the wall and so on. This is the 3x2 bottle system, the dripper near the bottle, the plants in bottle, 2 plants per bottle, maramaya and leaf vegetables in general. We also experimented this little bottle system. We are in Tulkarem, not in Gaza Strip, and after, well, also of course the training courses. And in Gaza, there were a big problem of food insecurity. These systems, and the problem of sugar chocolate addicted. The food, the cheaper food, and with the most amount of calories that they can find. This is quite strange issue, but main of the shops, of food shops, are full of chocolates and sweets and so on. After 2 months, at the end of April 2018, we came back, and this was the situation. I can see big production overall in the bottle systems. This is the courtyard of Umbra school, and also the families of the women of the women's center or the refugee camp. Well, okay, just to show you the results. Okay, this kind of garden were also illustrating this comic book. Is this one? I don't know if you can see me, or because I know you see the presentation. Where it's also said that drones are regularly sent to Gaza by Israel, of course, to monitor, attack, and spray herbicides on the crops to limit and control the availability of food. This, of course, before the last war. Okay, what I brought at home by this experience is the smile of this woman as she told me that vegetable gardens for, I'm sorry, for air, above all, a means of family residence. Okay, this is air garden. So residence is not only growing vegetables, but also beauty. Okay, if you want, I don't know if you have time. If you want, we can go ahead. Tell me something.
Yeah, you have time, don't worry.
Okay. Sorry. And okay, just few numbers. By this kind of simplified hydroponics system. In Myanmar, the sampled area is 1,600 square meters, more or less. The growers involved 1,000, sorry. In Brazil, 972 square meters, and so on. The gardens, the lecture are related to the kind of gardens, A, family gardens, B, community gardens, C, experimental gardens. And well, the total was is 1,700 more or less square meter of area, and almost 2,000 people involved. The average annual yield in total is between 20 and 40 kilogram for square meter, comprehending all the different systems. So 20 to 40 kilogram for square meters in a year. You can see here the Garafas PET system seems to be the less efficient, but the reason is that in arid and semi-arid climates, so this is the reason. Between 2 and 7 square meters are needed to feed one person. In general, the growers involved after the project, of course, eat more vegetables, fresh vegetables than before, and the project, the gardens was for both commercialization and self-consumption in Myanmar and Brazil, just for self-consumption in Peru and Mauritania, and primarily for commercialization in Namibia. Of course, the cultivation area needed to secure a minimum wage that is different in different country. The water efficiency was much better than in soil cultivation in the same area. and of in mean 44 gram of product for per liter of water in Teresina, and 37 gram of product for liter of water in central dry zone Myanmar in the desert. The success of the project, sorry for the Italian, the success of the project is linked to some factors, the knowledge, and so are needed practical technical training and also technical assistance. A good organization, so defining a good defining of roles and shared responsibility, and simplification, so the use of local and inexpensive material and tools for the nutrient solution preparation, such as fresh, that is Excel sheet, quite simple for the nutrient solution preparation. In the end, less than 7 square meters of garden can feed one adult, less than 7 square meters. Gardeners increase 3 to 10 times their vegetables consumption, fresh vegetables consumption. When product is sold, less than 100 square meters are enough to provide a minimum salary in Peru, Mauritania, Nigeria, Palestine, and Namibia. Growing system may need less than 1 liter of water per square meter per day in closed loop systems, and construction cost can be reduced, of course, when using durable, even if it is more expensive materials. Okay, thank you for your attention, and sorry for the delay.
No worry. Thank you, Giovanni, for presentation. Dalby, if you wanna start.
Thank you. I hope you hear
Sorry,
me well. Thank you very much, Giovanni, for your presentation. It was very interesting. Do you hear me and see the screen?
Yes.
Okay, give me 1 second. Okay, you still see the screen correctly, no? Okay, thank you very much. So my name is Nicola D'Alberton. I'm a research fellow at the C3A from the University of Trento, and I'm part, as part of the UNESCO chair in Engineering for Human and Sustainable Development. So I'm very happy to be part of this webinar. And today we'll talk about precision irrigation in the context of environmental cooperation, especially with this case study in Lebanon. I will start a little bit with the challenges that Giovanni already introduced. So we are facing, the future generation will face big challenges due to the fact that agriculture is the main water using sector. The population is rapidly growing, and more than proportionally, the food demand is increasing because overall quality of life is increasing. As well, another factor that we are leading to as a consequence of deforestation and improper agricultural practices is the fact that we are facing more and more soil degradation conditions that allow us to have less production, and we need more and more from the same land, and we have more and more issues related to this topic. As well, of course, another topic is the climate change that we are facing, in particular the increasing of temperature, change of rainfall patterns, and even other extreme events. So, very brief context to frame the topic is the definition of evapotranspiration that most of you may know. That is the combined process that moves the water from the earth, is a component of the hydrological cycle, and is composed by the part of the water that moves from the soil, the canopies, and the water bodies directly, which is evaporation, and the one that transpirates through the stomata and so through the plants. The evapotranspiration depends on climatic condition, crop and land cover, and as well on the water stress condition of the plants. This means that if we give for a specific crop that we are growing a line, which is in this example is the red line, that is the water that the plant demands for a correct growth, and we draw as well the amount of rainfall that falls, which is the blue line, we see that we have a period of deficit and period of surplus. The fact that the climate change is we are rising up the red line, having more deficit because the temperature requires more, puts the plants into a more requiring condition, while the blue line decreases because the water may fall in very intense events, which are characterized by high runoff and therefore losses. This water cannot be used by the plants. So the concept of precision irrigation is to know soil, know the crop, and try to provide the correct amount of water in the correct position corresponding to the demand of the plants. Here, very briefly, we can have several solutions. The condition of saturation, when there is too much water in the soil. And so this water is lost through deep percolation. The field capacity is let's say, the perfect amount because it doesn't generate too much deep losses, and it keeps the plant on health. And we have another limit that is the wilting point that may lead the plants to very stressful condition and eventually even the death. So the game is to try to keep, depending on the specific situation, the amount of water in the correct range. Another topic which is very relevant is related to the irrigation efficiency, because from all the water that we withdraw, we may lose a lot of water through the piping system. And so there is the definition of conveyance efficiency, which is the water that we lose through the transport. And then the field application efficiency, which is highly dependent on how we irrigate. For instance, a surface irrigation has 60% of efficiency, so only 60% of the water that we give will reach the roots, while a drip irrigation has a way solution. How can we face these problems? For instance, Giovanni showed one of the way, which is soilless. Otherwise, there are enhanced the hydraulic system to improve the efficiency I just mentioned. Choose more proper crops that require more resistant to more severe situation. Work on soil and retention capacity. For instance, with soil practices, mulching, water harvesting, and as well to provide the correct amount of water in the correct time, which is basically what we're trying to do in the concept of precision irrigation. As well, of course, yeah. So this was a brief introduction. We move into Lebanon, where I'm currently staying. It's a small country that has a Mediterranean type climate. Is not as dry as many people think, but because it has mountains, but it has a period of deficit of water for irrigation. As well, of course, even in Lebanon, climate change is expecting an increase in the temperature and a decrease into the precipitation. In this framework, so the project I'm working for is called Saving Water Growing Crops. And it has the aim to increase the adaptation capacity to economic losses induced by climate change through an efficient use of the water resources. It's funded by the European Union and Svenska postcode Stilson, I'm sorry, the postcode, the Swedish Postcode Foundation. It has a lead partner, Italian NGO that is called Istituto Oikos, and we're working as well with the National Reserve of the Shuf Biosphere Reserve. The technologies in particular that we're trying to implement to face climate change are rainwater harvesting, smart precision irrigation solution, and as well as solar pumping system. We're working in particular in two areas. One where I'm close to where I'm located right now, that is on a small households condition in a mountain area in the Shuf. And we're working in 20 hectares. And another area which has a more, let's say, agro-industry context because it's plain, has is in the Bekaa Valley that is close by and has a more a different system that we're using to try to monitor and quantify the efficiency of the system that we're proposing. So we have two very different contexts I was mentioning. The first one, as you see from the picture on the left, is characterized by different crops, a mountain environment, poorer soil, and small-scale agriculture producers. As well, you see from the picture, the irrigation method, the one down on the left, was not very efficient. And the one on the right, instead, is a more agro-industry situation where, let's say, the orography was plain, the production was a bigger scale. Here, a brief overlook on how the system was prior to the intervention. It's a bit complex, but I will go just to the main topic, which is we were relying apart in water harvesting, but we had big problems with sediment. I will show you more in details later. And we were relying as well on a pump that was alimented by fuel and hence with a high, from a fuel generator, hence with a high consumption of CO2 emission, that was particularly a problem because Lebanese situation faced a fuel and economic deep crisis in the recent years. As well, there were high losses throughout all the distribution system. So what we tried to do, it was working from the beginning in trying to get as much possible advantage of the rainwater through rainwater harvesting and limit the sediment entering, moving to a solar alimented pump, enhance the distribution efficiency, move to a drip irrigation system, and as well, we are recurring to a technology that allows us to, and allows the farmer to see the amount of water in their fields through soil sensors, visualize them into an application, and regulate the, this gives an advice in terms of irrigation that can be applied directly from the devices. So, briefly, our wishing were mostly to have a more efficient irrigation through the adoption of irrigation strategies, to reduce inequalities, because previously the system was with a lot of illegal connection, and basically the water was going to the farmers that were more lucky as for the position of their fields. And right now, the new system is providing homogeneous irrigation within all the pool area. And as well, it's very relevant, and what we're working on now is on the operation and maintenance, because the system got way more efficient, but it requires a proper maintenance. So we're introducing a tariff that the farmers can contribute, and providing a maintenance manual in order to guarantee the maintenance. As well, there is the formation of a water committee, a group of local people in which roles are defined in order to gather the contributes and intervene in case of any maintenance topic. Here's some picture of the rehabilitation of the pond. You see, in particular, in the left, you see the problems with the soil, that is way decreased by the presence of the sedimentation trap. That is the one you see in the right image. So this system, in particular, is collecting runoff water, draining into a channel that is located on the side of an agricultural road. This led to a sedimentation trap. I don't know if I can put the laser pointer. You see the laser pointer?
Yes, we do.
Okay, thank you. So the water reaches the sedimentation trap, where the sediment is settled down and removed, and then this water reaches the pond. Here, some picture of the smart irrigation components, the installation of a meteorological station and soil humidity sensor, and we are relying on an application which is an Italian brand called X-Farm, that allows, let's say, to visualize real-time data. For instance, this is an example of the soil humidity in order to take data-based decisions. Here, a quick overlook on a rain event that took place, and how this affected the soil moisture, and how this increased the water level into the ponds, in order to be seen by the farmers. Here, an example of the remote controllers that remotely can monitor the system. Activate and deactivate the system according to the strategy proposed. So the role of the University of Trento was technical support and as well the monitoring. So basically, we tried, here is an example in which we see into a specific crop, and we see that the blue line is the field capacity that I mentioned at the beginning. So going over this line means that there is too much water, and this water goes losses. If we go behind this dotted red line, we are probably reaching a more stressful condition for the plants. And so the game here was, after a first over irrigation, which we are going over the blue line, we tried to adjust it with a more rational schedule based on the data. Here, a picture of the photovoltaic pumping system that we've been installing. It showed, of course, good results in terms of kilowatts used per hectares, because the pump is more efficient. As well, all the energy is produced through photovoltaic systems, so the CO2 emission are way reduced. We are monitoring the water table since the beginning of the project, and I think that we noticed is that last year, for instance, there was, due to the fact that we had a stronger instrument to withdraw water, even though it was used in a way more efficient way, we saw a high consumption. This is called the Jevon paradox, and it's something that we should take care of, because not to and to monitor that the quantities of water taken by the groundwater are not damaging the ecosystem. Here a little bit some analysis that we could do, passing through 3D modeling of these ponds that we saw at the beginning, that allowed us to quantify the amount of water harvesting water and the evaporative components, as well that could be validated through the irrigation amounts that were as well measured to fully understand how these water harvesting structures were working. Here, a brief concept that a master thesis student helped us to do from energetical engineering. He's as well from Lebanon. That helped us to try to quantify in how many years the saving guaranteed by some intervention allowed us to save water, to how much energy we saved, and as well to quantify the CO2 emission, of course, and the payback period. So how many years for the investment to be paid back by the retention, which are actually good results. Here, I hope I'm not running too much for the time. These are briefly the results that we had from the first year. Actually, we had a first rushing year because we managed to finalize the works relatively late. So we have a partial irrigation season, and therefore this year we are further monitoring the system to, let's say, have more solid results. And we saw quantity of water provided to the plants similar as the previous, with more frequent application that provided good theoretical yields with more uniform distribution. Very good results in terms of runoff water harvesting, that hence the last year allowed us through a co-financement to enhance it further, like to have an even bigger area because we could save it, and some results in terms of water saved and payback periods. Of course, these results have to be seen through some consideration. For instance, as I was mentioning, since we are increasing the irrigated area, even if it's way more efficient way, we are overall going above with the withdrawal from the aquifer. So we should take care of these and monitor the aquifer behavior. The plants brought collaterals, but we had, for instance, this year big events in terms of hailing during the flowering period that led to big impact. So we didn't see an increase in the production due to other climate change related influences. And yeah, and as well now what we're facing is a more complex management, and so we're working as much as we can with the local community in order to work together to find solutions, to find ways to cover the expenses, to intervene promptly, to in case of damages or leakages. And yes, this is mostly it. I will briefly conclude with the main challenges that we faced. In particular, we had a lot of difficulties related to, well, first of all, there was a very big economic crisis, COVID, some external factors, the complete absence of cadastral plan that we faced, and what I think it's being pretty much successful. This project what I want to leave as message is that I think that the very central component of each kind of international cooperation project is to promote a participatory approach that directly involves the local community in all the phases, because to my experience, this was one of the most relevant component for the successful or fail of a project. I will skip the other points, but we can develop eventually during the question part. And I would like to thank you very much. Here some links and some references of the presentation in case you want to develop, but we will be sharing with you all this information. Thank you.
Thank you, Nicola, for presentation. So now let's do, if someone has a question, any question? So, no one?
I have a question, if I may.
Yeah.
Could I ask?
Oh, yeah, we can start.
So I present myself. I am Alberto from Lebanon, actually. So I'm very interested in the topic, even though I'm a PhD student in food science in the University of Trento. So I would like, I have a background in agricultural sciences and I'm an agricultural engineer. I would like to ask about two questions, actually. First of all, if there is or there may be in the future any collaboration with the public sector, maybe with the Ministry of, I don't know, of Agriculture or the Ministry of Environment in Lebanon for, let's say, expanding these technologies throughout Lebanon, and also about the costs. What do you think about that? And the second question is about, let's say, the resilience or the resilient aspect, considering the southern part of Lebanon and the bombing issues and the contaminations in general, the water contaminations in Lebanon, how we may deal with that, even though this question is a little bit far away from the topic. Thank you.
Thank you very much, Alberto. Okay, to go back to the first question, yes, I mean, this is a pilot project. I didn't mention is within a group of projects that are dealing with climate change, and there are 7 pilot projects distributed within the MENA region, so Northern Africa and the Middle East. In particular, yes, we are involving, and we had several meetings with the ministries that actually showed good response. We are as well part through the European Union of the West supporting program, which is a program that is supporting us, and as well we came with some colleagues to Bari, to the camp, to have a formation and to develop the communication with the ministries, which is pretty much active. In terms of cost, yes, this is of course a central topic. I think that this kind of technology has to be thought within. For small farmers, often it's a bit difficult to guarantee the full installation of the system, and could be done, for instance, in more municipal level. If, for instance, there is a scalability, if several farmers apply as a group of farmers rather than a small house, a single, which can reduce the cost. And as well, for instance, the big industry, since they normally have higher income and higher energy and water withdrawal, And of course, a little reduction into a big number would guarantee big savings, which is the case in the Bekaa where we are working. That is, which they are spending a lot of money for pumping, and so I think that context it's a good solution because it's directly affecting the expenses of the farm. Concerning the second question, of course, is a very big topic. There were in southern Lebanon the use of phosphorus, white phosphorus on agricultural lands. This is probably something that is more dependent on geopolitics than directly on the agriculture. So I feel like the resilience of farmer is I have a lot of friends that are still going to the south, growing their olive trees and getting them. But of course, it's very a geopolitical topic, so I don't have a precise answer on this topic.
Yeah, this is always a critical issue. So thank you for this very great presentation.
Thank you.
We have another question from here in presence.
Hi, my name is Andrea. I study environmental engineering in Trento, and I have a question for Giovanni, more precisely on the Garrafas PET systems. I'm very curious about maybe the mean cost of one of these systems and its longevity, since it's made of water bottles. I'm very curious, like, for how many cultural season you can use them and how much investment it is to keep them in good conditions in general on a long term. So yeah, that's my question.
Sorry, I have the audio problem, but I'm not sure I catch the the question very well. It's about the cost of the systems.
Yes, and also the longevity of the system and the investment in terms of time and money to keep these systems for working for a long time.
Okay. Well, of course, the project we did in Gaza where was emergency emergency project. Of course, our main our main issue was the replicability and also the possibility of the continuous the project after our left. And well, the costs the costs are quite low because we used, as you have seen, material very local material, easily available and cheap. So wood or iron or something easily available, and the investment, of course, depends on the number of of the gardens of the module. The most productive model is the bottle system. In this case, the investment can be, I can't remember very well. It was about $300 for module. But of course, the investment is just for once, and can be provided by a project. The important thing is the management of the systems, from the point of view of the costs, but also, and this is the bottleneck, the knowledge, the know-how. This is very important. It's very important to train people interested in this project. We trained some students of the agriculture university of Gaza City, of one of the university, and association of farmers association. We built as we tried to build as in Brazil, a hydroponic house, a hydroponic center. I'm afraid it is the target of a bomb in this period, but until the last month, the center worked well, and I think in conclusion, I think the cost is not the bottleneck, but is the technical knowledge and the technical assistance, and capacity of involving farmers and people.
If I just wanted to add a curiosity or share of the topic, because yeah, through ESIC, I started to talk with Giovanni, and I really liked the idea of these soilless simplified techniques. And apparently, right now, I share the ideas with some friends here in Beirut, and most likely we will be starting to develop a little system with a community involving a little soilless technology. So this is a good results given by these networks, and I would like to thank Giovanni first.
There are other questions? In the chat? Okay. There is one question on the chat for Professor Bazzocchi.
I don't know much yet. I was wondering how. I can't catch water logging. What is logging?
I think it's clogging. or lobby?
I didn't hear. It is.
Water saturation.
Okay. Water saturation.
Sorry. Well, the floating system in the floating system, the most important thing is the oxygenation of the water. Of course, this is a system quite difficult because all the parameters should be well regulated. The temperature, the pH, the EC, and so the nutrient amounts, and also the air, the oxygenation. In the other systems, there is always a substrate, and so there is a buffer. A buffer mechanisms similar to the soil mechanisms. So, of course, the irrigation has to be well regulated depending on the environmental conditions, the weather, and so on. You can, for example, in the bottle systems, you can temperate, you can add a timer to the tank to do, for example, just 2 or 3 irrigation loop a day. Of course, depending on the weather and the environmental conditions. But there is in any way the buffer mechanism covered by in a similar way of the soil.
Here we have another question.
First of all, I would like to thank you both for your enriching presentation. I have a curiosity, especially on, I was curious about how was the level of the engagement of the local partners and also of the beneficiaries you work with. Maybe for the example, for the social housing or the Gaza project for Giovanni and for Nicola, the Shuf in the Shuf region. Thank you. But maybe you can answer really quickly because we are running out of time. I don't know if you can give us a tip or something. Thank you.
I don't know, Nicola?
Yeah, you can go first. Thank you.
Okay. Well, of course, there were 2 very different situation. In Gaza, there were a project. Of course, there were local partners, association, the women center, the 3 schools, so the teachers of the schools and so on. And I have to say that overall in the Women's Center, the little systems were very, very well view by the women and the women, and most of them replicated the system at home. We gave from the project the material, and they replicated the little box system, 1 meter, 1 square meter at home. I of course I have got news in these days about these systems because of the war. In the rooftop garden in D'Annunzio, Bologna, well, the project lasted 5 years. Also, well, the real project was of 2 years, and the garden lasted for 3 years more, with some problems. With some problems among the residents, because the situation was quite problematic, and there were very different kind of people. But I have to say that this project has been one of the more challenging for us, but also one of the more beautiful from this point of view, because at the end the garden was a place where people met in a quite peaceful way, and well, I have to say that at the end the project it was a success. It doesn't exist now, so this is pity, but for 5 years was a very good project.
Thank you. I say very briefly about the engagement into our project. Of course, it was very different. Most of people took it directly good. Some of the people I'm facing now a little bit shift, people that were more skeptical that are now less. Maybe the 2 ingredients that I noticed were that mostly young farmers were more likely to be participating in innovative techniques, while older are more used to their practice. And another thing I noticed was that at what point they were involved, because what was the role of their impact. So I think that some people that got relatively at the beginning of the project within, they felt to have more importance, more relevance, more opportunity to learn, and this was a relevant factor according to me.
Thank you, you both.
There is a last question.
Very briefly, good afternoon, friends. Massimo Zortea. In terms of capacity of building of the beneficiaries of the two different approaches, very simplified in the first case, Giovanni, and with a higher level of technology and complexity for the experience of you, Nicola. What about the capacity development of people? Have you developed some handbooks or materials in order to establish a legacy of your efforts, especially in the first case, because probably in the second case it's more complex, but I'm very curious and of course interested also in the slides. Please collect the slides of friends and give me. Thank you so much.
Well, about Palestine, it's difficult to say if well, of course, the situation is extreme, and was also at the time quite extreme, and the capacity building is not so easy. But I mentioned before the participation was very enthusiastic by the women and by also the farmer association. I can say that in other projects such as in Teresina, Brazil, in Piauí, the project is running also today after 20 years, and this is for us, of course, a very good a success. I mean, of course, not the same, of course, for other projects. It depends on the of course the social and political situation of the place.
Yeah, I answer about the capacity building in our context. Yeah, it's more complex. So of course, all the people had a formation about how to benefit from the systems, how to direct manage it. And yeah, for us, the main core of the capacity building was towards a group, which was this little water committee. It's fun to talk about water committee for such a small dimension, but it's actually recognized. We worked with the municipality. Rules are well defined, and as well we developed supporting material, for instance, manuals for the formation, and currently these days I'm mostly we are working all together, especially with these focal people from the water committee, in order to follow up and do, let's say, this hand-on of the project and the management.
Yeah, the focal point, if I can add just I think, is the training for trainers. The main the main issue is to find before starting a new project, local farmers, in our case, interested in the project, because they can become afterwards the main capacity builders of this kind of projects.
Thank you very much. I want to thank again Professor Bazzocchi and researcher D'Alberton for the presentation and for the disponibility. And thank you also again to the Professor Bazzocchi who has mentioned Gaza. So thank you very much. I would like to remind to everyone that next week will be the last seminar about nature-based solution for sustainability of city. So I hope we will see you next week.